Okay, so we're going to look at vectors day 2, part 2. First of all, this is X, this is Y. What's another name for these two sides of a triangle? Think back to SOHCAHTOA. This would be what? Opposite. This would be adjacent. And this would be hypotenuse, right? And we already know the hypotenuse is the magnitude. So what's the ratio for cosine? Let's review that. What's the ratio for cosine in trigonometry, SOHCAHTOA? Adjacent over hypotenuse. And what is sine? Opposite over hypotenuse. I told you these just never go away. So if cosine is adjacent over hypotenuse, what is cosine? X over magnitude, right? Adjacent over hypotenuse. And remember, these are kind of bold. And what would sine be then? Opposite, which is y, over hypotenuse. Now, if we know the theta and we know the angle, I'm solving for x. I want to know how big this side is, and I want to know how big this side is, y. How would you get x alone there? What do you do to get something out of the bottom? Multiply. So I'm going to multiply this bad boy. Right? Now those are gone, and x equals what? Magnitude cosine theta. Right? I had to multiply both sides by magnitude. Now what am I going to do here? And remember, these letters are bolded for proper notation. I should make that a little darker. Okay? Does that make sense how we arrived at this? And you mean to tell me we're still using trigonometry? It's that important? Yes. Okay. So now when you graph a point is x, y, right? X comes first, then y. But right, this is a point. This is a vector. How is a vector different from a point? What changes? The parentheses, right? Right, they're broken. Make sure your mask is up. It's got to stay up over your nose, guys. Okay, so we have the little bent braces, right? So component form of a vector, that means x, y. Let that sink in for a second. That means x, y, and we put our little bent parentheses. So x, y, what does we say our x is now? Magnitude cosine of the angle. Y is magnitude times sine of the angle. Well, let's see right here. What is the magnitude of this vector? Which one of those numbers is the magnitude? 23. What is theta? 40. So is there really any work to do here? There's no work to do. All I have to do is write it down, right? It's x is what? Magnitude cosine theta. Y is magnitude sine theta. So that's all I have to do here is write 23 cosine 40, 23 sine 40. Not bad. Is that easy? It's that easy. These two are exactly the same except what? One says cosine, one says sine. We already know cosine represents x, sine represents y. So now you get your handy dandy calculator out and you're going to type that in. Unless you have cosine of 40 degrees memorized, which I do not. Y'all, I put my calculator away and I don't know what I did with it. So y'all got to type that in for me. Where did I throw that before I left? Come on, y'all. What mode does your calculator need to be in? Degrees. Make sure your calculator's in degrees. So we're going to go to mode. And right there, if you've cleaned your calculator, it's going to be in radians. It always resets to radians. So go to degrees, hit enter. Now I'm in degrees. And I just type in exactly what I see, 23 cosine 40. It's that easy. Type that in and hit enter. There we go. If we are not given instructions, how many decimal places must we keep? That's right, 3. Until someone tells you to round, always keep 3 decimals. Trigonometry changes a lot with the decimals. It can make your answer get far enough. Y'all know that Delta Math, Math Lab, any of those math platforms where you type stuff in, if you're off at any one of those numbers, it counts it wrong. So we have to be very diligent. Trigonometry gets wrong real quick. Okay, then 23 sine 40. There we go. Not bad for the first day back from Thanksgiving, right? Not too hard. Is that okay? Okay. Now we got this one. Find the components of the vector with a direction of 225 and a magnitude of 25. Well, I think it's handy to get this in your head so your vocab makes sense with your notation. What is the magnitude? And what is theta? While you're new at this, identify those. This helps your brain keep remembering what you're typing in instead of just putting numbers into your calculator. So once I know these 2 things, is it really hard? No. So what goes first? Magnitude. Then what? Cosine 225. And don't type it in yet because I want to see if you're thinking. Now, before you type this in, I want y'all to think. Where is 225 degrees? It's right there, right? So what can you tell me about both sine and cosine in this quadrant? They're both going to be negative. And what can you tell me about the number you're going to get out for both sine and cosine? The same, because it's a 45-degree angle. If you know that going in and you make a typing error, something's wrong, you're going to be like, wait a minute, that was a 45-degree angle and I know sine and cosine are the same. Okay, so let's type it in. Or if you were taking a test that required time, would it speed you up if you knew that was 45 and they were the same numbers? You know they are, and then in this quadrant, they're the same sign. Okay, did everybody get what I got? Okay. If this is strength, how can we have negative signs? Because this, what do the negative signs mean? Do they mean I was going backward in time? That I had a negative speed? No, it means I'm going left and down, right? That's what your negative signs represent. If it's with the Y, you're going down. If it's with the X, you're going left. True? So let's not get scared when I see negative signs like, ooh, okay. Find the component forms of a vector. Oh, what's 200 miles per hour? Is that my angle or my magnitude? Magnitude. So I'm going to do my skinny little bars with my bold V. In a northwesterly direction. Oh, I have to figure out which way that is. So let's remember north, west, south, and east, right? They're expecting us to know that. And it says exactly halfway. If you see northwest or southeast or whatever, and they don't give you any numbers, that means halfway. It's at 45. Okay. So where is northwest? So now y'all have to figure out how big that is. How big is it? Well, this part is 90, and then I add half on, which is 45. So what is theta? 135, right? Because I have 45 here and 90 there. So they're expecting, if they don't tell me, that I can figure out halfway. Okay, once I know this, is it simple? Now, what kind of an angle is this? It's a 45-degree angle. So what's going to be true about the numbers for sine and cosine? Numbers will be the same. Will their positive and negative be the same? No. Cosine should come out negative because we're on the left. Sine should come out positive. Think about that before you type stuff in. So if you make some kind of mistake, you're like, hey, wait a minute. My sign is off. Something's wrong. It helps you figure out. All right, type it in. What are we going to do? 200 cosine 135. And right now in your notes, I highly recommend that, oops, I always do that. That's my worst mistake. I write cosine twice because I don't know why I do that. Write these down while you're taking notes because that's what you're going to look at when you start an assignment, right? Let's type that in, 200 cosine 135. Now, if I'm wise, I don't have to type that in again. I know it's going to come out positive. Of course, I'm going to check it because if I hit, let's say I accidentally hit 145 when I typed it in, it's going to tell me that it's wrong if they don't match up. What happens when you type the other one in? It's positive 141.421. And that's exactly what we said it was going to be, right? Okay, easy. Whoops. Now we're done. Any questions over this? This feels good after everything we've done, right? We're like, something not too bad. All right. The wind is blowing 20 miles an hour at a bearing. Oh my goodness. Can we type in 30 degrees here? We cannot because we defined a vector measured from 0. So north, west. All right. So north 30 degrees west. So there's north and I'm 30 degrees on the west side. So if this is 30, I'm looking for this green angle. And what is that? What does theta equal? How big is theta, y'all? 120. Because I'm starting from 0, that's 90, and 30 more makes 120. Now, what do you know about sine and cosine up there? Sine will be positive. Cosine's going to come out negative. Okay, here we go. Oh, do we know magnitude? 20. Is that a strong wind? It's bad enough to make you tie everything down if you're going to try to eat outside, right? Can't use paper plates in 20-degree wind. We know this. We live in Texas and it's windy all the time, right? With that, and can y'all answer a question for me? How come in Texas, when it's 105 out, there's not one bit of wind, but when it's 30, the wind just whistles right through? Do you ever wonder that? Why can't we have the wind in the summer? I know it's okay. So vector, we're going to have magnitude. There we go. So magnitude cosine 120, right? 20 sine 120. And y'all, I highly recommend you write these two things down. It will keep you from switching those numbers. It's very easy to go onto autopilot and write 120 cosine 20. Very easy to do, and then everything goes bad. So tell me what you get. Wait, cosine of 120 is a half, so that's going to be negative 10, right? If you get one of your 30s or one of your 1/2, it's easy. Everybody okay with finding the component form? Easy, right? Well, what if we have more than one vector, right? What if somebody's helping me to push a desk? Both of us are pushing. All we have to do is find each vector like this, and then we just add the x's, add the y's. It's that easy. Okay, let's look at this. This looks like somebody's helping me move a desk, right? So what is this one going to be? They gave us magnitude and they gave us the angle. So this is going to be 6 cosine 20, 6 sine 20. There we go. Now we got this one. Someone's helping me push the desk across the floor. And we've got 3 cosine 150, 3 sine 150. Now you don't have to write these down individually. We can type them in together. So you could just do 6 cosine 20. Make sure you close the parentheses on this one or else it will goof them up, plus 3 cosine 150. Close parentheses or it'll stick the second one inside the first one. 3.040. If you don't put that that 0, then you haven't rounded to 3 decimal places, right? So even if it's 0, it's important. That signifies you got to the 3rd place. Some of us are having trouble on delta math when we key stuff in and it says to round, which I want to point something out. Let's add this one up. See if you got what I got. Is that okay? And I want to point something out real quick about rounding. Okay. When delta math asks you to round to 2 decimals, okay, I've got people saying, well, 6 would change. Actually, I'm going to do, hold on. I want one more. If you're rounding to this, what number do you look at? You look at that one. Nothing past that, right? You look at this, so that would be 4.44. I've got some people, and it's quite a lot of people in all different classes from calculus to everywhere. They look at this 6 and they say, well, this 6 would change that to a 5. So then that 5 would change that 4 to a 5, right? They're going all the way out to the last number they see and rounding all the way over. Don't do that. If you're rounding to this number, you only look at the number next to it. You do not go out and start rounding everybody up, okay? And think about it. If this were money, 44 cents, is that closer to 44 or 45? Kind of think about that. But anyway, make sure when you're rounding, you only look at the number to the right. You don't go to the edge and start rounding everybody, right? Okay, I just want to make sure because we're rounding on all of these. Okay, now we're looking at a plane and wind. So a plane is flying at a bearing of north 65 degrees east at 500. A tailwind adds to the plane's velocity, blowing north 35 degrees east at 80. Express the actual velocity of the plane as a vector. Determine the actual speed and direction of the plane. So what the speedometer says, right, what it says the plane is doing and what's really happening is different. If you're driving in your car to Amarillo, you know West Texas has wind. If that wind, how many of you have ever driven the car in a wind that's blowing against you really hard and you're kind of steering like this because you're really windy. If the speedometer says you're going 60, are you really going 60? Are you? Or is the wind blowing?
like the speedometer is moved to, it doesn't know that the wind's going. Oh, yeah.
Well, now there's a conundrum we're going to investigate in a minute. Okay, so let's look at this. First of all, y'all, you cannot do these without paper. So when you start your homework, you should have a piece of scrap paper out. Actually, I would do them on paper and keep it because I can look back at them for a test. But north 65 degrees east. North 65 degrees east. So that's right here, right? So what number do I actually want? This is 65 and I need to measure from 0. How big is that? 25 degrees. So for my plane, right, theta equals 25 degrees. And I'm going to do a P for my letter so I know it's the plane, right? Now I'm going to do the wind. So all right, a tailwind adds north 35 degrees east. North, east. So what number do I actually want for theta? 55, right? And the magnitude is what? 80. Everybody okay with this? Once we have this, it just repeats what it used to do, right? So we're going to have plane plus wind actual. Now I want you to write those words down because sometimes they'll give you the actual. If they gave you, well, we'll talk about that in a second. So the plane is what? 500 cosine 25, 500 sine 25. And we're going to do the wind, which is 80 cosine 55, 80 sine 55. Now, what do? I just type those into my calculator. So type those in, add them up, and see what you get. But do your work this way. When you're doing delta math or anything like that, write this out so you can see it. It will help you remember better. And I notice we're getting to where we're not writing anything down. Like y'all take notes and then you put them away to do your homework. We need our notes, right? True? True. All right, what'd you get? I got 499.040, 276.841. Did y'all get the same components that I got? Did we answer the question? What does the question say? The actual speed is the magnitude. We got it into component form, but now how do we find the actual speed? How do you get the magnitude out of this? Yes, so magnitude equals what? The square root of 499.040 squared plus, and make sure you write this down. Right? This is the important thing. This is what you need. So you're like, how did I do that? I don't know. Does anyone know what that's called when you take two forces and you add them together? Do you remember from physics? Starts with an R. What force is that called? Starts with an R. It's called your resultant, right? That's your resultant because it's the result of putting those two together, right? So your resultant force. Okay, what'd y'all get? I got 570.685. Did y'all get that? Now, in your calculator, you can just go up and capture this number, square it, plus capture this number and square it. Do y'all all know how to go up and capture numbers in your calculator? Okay, so if your calculator's on, okay, let's say I want to do these. These are different numbers, but that's okay. You just go up and highlight it and hit enter. And now I can just hit the square button. Then I could go back up and say, oh, I need the 3. I could hit enter and square it. Of course, I forgot to put a plus sign in between, right? So second insert plus. So you can go up and capture and you can get the whole decimal. You don't have to retype those. Do y'all know how to do that? Okay. Huh? Yeah. I didn't know that either. And in calculus, I was typing in these huge integrals. And it wasn't until I'd done a lot of them that someone said, you can just copy and paste. And I was like, what? A calculator does that?
No, I didn't know you can just put a plus sign in the middle.
Oh, sure.
I was like, she's gonna have to retype it.
No, second delete, second insert. Yeah, I used to retype everything too. Yeah, there's many things your calculator will do. If you come up with any tips, please share them with us because I in no way know everything that this calculator, the shortcuts like that, I don't know them all, right? And then you could just go second square root, second answer. And this, of course, would have been a previous problem. But anyway, there we go. Okay, so 570. Did everyone get that? Remember, you must be careful. If I were grading this by hand and you had a decimal off on a thousandths place, I wouldn't mark it wrong. But what's Delta Math going to do? What's Math Lab going to do? They're going to mark it wrong because they're programmed to go, right? Now we need to know what direction it's going to go. So what's the direction? Tangent, inverse tangent, right? And what do we put in there? Y over X, right? Again, you can go copy and paste. You can go capture. So y'all tell me what you got for your degree. I got 29.019, right? Y'all know how to type that in, right? You just go inverse, which is the second key, tangent. There we go. Everybody good with that? We don't let you use a calculator for so long. When we finally give them to you, it's like, what do I do with this thing? I don't know how to use it now. Okay, so now, everybody okay? We got a thumbs up? Let's see. People at home, do you have a thumbs up? Give me a thumbs up, folks. Okay, now is your test, right? For example number 7, I'm going to give you a few seconds to do it. All right, that gave you some time. Here are the answers. Does anyone want to see that worked out? Okay, so, oh, a small plane is, so let's do vector P, right, is 180, north 50 degrees east. So there's north, there's east, north, 50 degrees east. So what number are we actually going to use? we're going to use 40. So theta equals 40. Now we've got some wind blowing. Okay, from west to east. This is west, this is east. I'm going from the west to the east. Okay, so what degree is that? How many degrees is it if I'm going this way? 0. If I was going east to west, how many degrees would it be? That'd be 180, right? So you got to read, we're going from west to east. So you have to read your direction, 40 miles an hour. Is that what made that one hard? What challenged you was that part? Yeah, good. I'm glad we saw that. So we're going to do wind. Wind plus plane, right? So what's that going to be? 180 cosine 40, 180 sine 40, plus 40 cosine 0, 40 sine 0. Now you don't even have to type these in, right? Because you know cosine of 0 is 1, so you know that's plus 40. Sine of 0 is 0, so you're not really adding anything to sine, are you? Right? Okay, so let's add those up, type them in. And I got okay, so type those in, punch them in, and there we go. I'm going to call this R. You could put P plus W or R. R means resultant, right? What is the magnitude? Is everybody okay? Once we get it to this form, no trouble, right? On that one, the problem was figuring out your degrees. So remember what that said, from the west to the east. And then, of course, second tan, which is tangent y over x. Is that good? Now I want to ask y'all a question. There's not an example here, but I think one will come up in your work. If the plane plus the wind equals the resultant, right? What if they gave you the resultant and the wind and wanted the plane? What would you do? What does the plane equal then? R minus W, could you do that? Or the wind equals R minus P for plane, right? So you can, if you're given a resultant, you would just subtract one of the other ones, right? Okay, last but not least, what about this one? Two forces act on an object. Now here, what we're practicing is this word. What does that mean? Means in order. So if they gave me two forces, 10 and 30, and two directions, that means the first force goes with the first direction and the second force goes with the second direction. Does that make sense? That's what the word respectively means when you look at math. So what are our equations going to be? 10 cosine what? 70, 10 sine 70, plus 30 sine, 30 cosine 25, right? 30 sine 25. So let's key that in and then we'll look at what the homework is. I like to use R for resultant. That way I'm like, I know what's going on. I'll write down what I got. I think y'all are okay to type that in. And we always want to put our correct labels. These are pounds. Y'all have worked in physics a little bit, right? And you know pounds. What did I get here? Right, and we know that this is the same every time, right? Now, if one of these numbers is ever negative, when you square it, do you need to type the negative? No, because what anything squared is positive, right? So it will keep you from making an error. Write all the numbers down clearly so you can see. And I think that's the end of our notes. It is. Whoop, whoop. How's everyone at home doing?